All right, hello everyone. My name is Sarah Osell and I'm the head of B2B software marketing and communications here at ZVerse. Welcome to our Delivering on MRO webinar. We're going to talk all about how digital manufacturing is making maintenance, repair, and overhaul a reality today. A quick overview of our agenda today. We're going to kick things off with David Craig, president of ZVerse. Introducing some of our top 5 trends that we're seeing happening in the supply chain and digital manufacturing industry right now related to MRO. And then also give a quick demo of our 2D to 3D automation assisted engineering technology. Following that, we're going to have a panel discussing these top 5 trends with our industry experts here today. We'll introduce them in a minute. From there, we will have our live Q&A, so do make sure to submit questions at any time. You can also network with other attendees by introducing yourself, thank you, Martha, and pasting your LinkedIn into the chat. After the Q&A, we will have some networking breakout rooms, which we'll explain in a bit, but there will be a link that is pasted into the chat for you to join. Those networking breakout rooms will be going on for an hour. You're welcome to meet all of the speakers as well as connect with each other. All right, and with that, I'd like to bring on Davide from 3D PBM to introduce their sustainability ebook. It just launched today.
Thank you very much, Sarah, for having me. This is a very interesting event that I've actually been looking forward to for quite some time. As you mentioned, we've been so 3D PBM is a media company that specializes in the additive manufacturing industry. We also do a lot of market research, and every month we focus on a different key topic that we pick for that. We pick 12 topics a year. And for this month, we had been focusing on sustainability, and it's been really exciting. It's been so successful. We've had so many contributions from you and from so many other companies. You know, there's so much attention towards this topic. And at the end of each AM Focus that we do through our online portal, 3D Printing Media Network, we always publish an ebook. It's a totally free PDF, or it can also be viewed online. And that's exactly what we just released today. There is a link in the chat to download it. We basically collected all the most interesting contributions from this month, and then we provided kind of an analysis, a kind of a top level analysis of what we think the most relevant applications in terms of sustainability are for additive manufacturing throughout the different industrial segments. So of course, you know, it's always we try to look at the real application, you know, where it really makes a difference in terms of sustainability. And of course, we did this, you know, with contributions from you and from companies that operate across many different segments, you know, even large companies, you know, large material companies and service providers. So as you said, the link is in the chat to download it, and I'm available for any questions about what we do and what we did with the ebook. Thank you.
All right, thank you, Davide. And 3D PBM, I just want to thank for being such an excellent media partner for this event. All of our panelists are featured in this ebook, and we got an article with y'all, and that was so helpful for getting people here. All right, Davide, thank you for that introduction. I'm going to pass things over now to David Craig, who I have pleasure working with as the president of ZVerse. David.
Thanks, Sarah, and thanks to all our partners and people who are attending today. I'm excited about the event and excited to lead on this. And thanks to Sarah for kind of putting all this together. I'm David Craig. I'm the president at ZVerse. We're a Columbia, South Carolina-based company, and our focus in life is really on 3D content creation and the scale challenges that come with that. And it's really focused on making sure that there's plenty of content, plenty of manufacturable 3D assets for digital manufacturing, both additive and others. And we've been doing this for about 8 years. We started out with something that we call CAD as a service, just helping companies create files for digital manufacturing. And we've expanded into other areas. And one of the biggest areas that we're focused on now is helping large OEMs convert 2D files into 3D manufacturable assets for digital manufacturing, and doing that at scale. And we've been doing this with both traditional manufacturers, but also with on-demand manufacturers. So if you're familiar with Proto Labs or Xometry or Shapeways, we actually partner with them day to day as customers come to them and are looking to either print a prototype or a part or a short run manufacturing job. If the customer's files either don't exist or they're not manufacturable, they route into our system and into our technology. We help them get a file put together and sent back into the on-demand manufacturer system for manufacturing and shipping to the customer. So today, I'd like to just introduce what we're going to dive in deeper today, and what we see as the top 5 trends in digital manufacturing that are enabling maintenance, repair, and overhaul, or MRO. So, we're going to focus on digital inventory, local production, lifetime value, systems thinking, and automation. And I'm just going to touch on each of these briefly, and then we'll dive in, like I said, in more detail. And so a common thread in many companies is the overinvestment in physical spare part inventory stock, with the goal of avoiding downtime because of the massive cost that downtime can cost. But we've identified that through our research that 20 to 30% of physical parts go obsolete every year, and that obsolescence has a cost to it, not only in a financial cost, but also a waste and elimination cost. And with digital inventory, the idea behind it is that you create your 3D assets, put them in a catalog or a library, and they're available when you need it. So it allows you to lower your safety stock levels, or even actually just produce when you need it kind of approach in a local way. The second trend that we're seeing is that global production is going local with digital manufacturing for repair part production. And this one's a kind of an obvious one, but the idea behind it is that a field technician really doesn't care where his part comes from, whether it comes from a warehouse or it comes from a locally printed part. They just want it as soon as they can, and they want it to work. And so with 3D files available in an online catalog, digital inventory parts can be turned around in a day versus the average of many weeks that it can take with the stock out in traditional manufacturing. Our third trend is all about moving forward with materials, parts, and equipment that they've got to have lifetime value. And on the left of this slide, you see what is a traditional linear economy approach, which is we need something, we make it, we use it, and when it breaks, we throw it away, and it goes into a landfill. And this is changing with the concept of a circular economy. And Europe is really taking the lead on this with the right to repair laws in France and the UK and Germany and other countries, and really leading with what is, I think, what will be the way we all operate over the next few years is the circular economy. And so we all know about recycling. In business, for instance, metal offcuts or old parts can be captured and reused as raw material for new parts. That's an example of a circular material cycle, and today there's even a name for it called urban mining that describes that cycle. But there are more cycles that can create lifetime value as well. In the refurbished repair approach, that's where ZVerse plays. Any kind of equipment that needs refurbishment or repair can cycle back through a manufacturing assembly process. And the whole idea is that instead of replacing that asset or that machine, simply leveraging digital manufacturing to produce spare parts to help in the repair and refurbishment, and actually getting that asset up and online and working again. But these trends really can't happen without systems thinking, and that's the next trend that we see, which is this is all about getting out of silos and collaborating across organizations. So as an example, in order for a repair cycle to happen, stakeholders like the OEM, digital manufacturing service bureaus, and field service leaders will have to collaborate. So in order for a field service leader to get a part out into the field, the OEM needs to share a 3D digital inventory part for local production at a digital manufacturing service bureau. So those different constituencies will have to work together and connect. And the big problem that's been kind of holding that up, that we've seen anyway, is that legacy parts needed for repair have traditionally been communicated in 2D engineering technical drawings. But that doesn't work for digital manufacturing, because a 3D asset is needed in order to be able to create anything or print anything. And so that leads us to what we see as the fifth trend, and this is where we come in, using an automation enabled approach. We've been able to convert 2D PDF or paper technical drawings into 3D assets, and we use a tech-enabled process to do that. It's part engineer and a lot of machine learning into kind of creating superheroes out of our engineer, and enabling what we call on-demand MRO. And by preparing the 3D assets ahead of time, getting them into a library catalog, parts can be produced and delivered locally on demand as they need it in very quick cycles. I'd like to show you a quick demo of one piece of technology that we leverage. So when we go through and convert a 2D file into a 3D asset through our technology, there's a big QA process that goes on, and some of that is, traditional human QA, but we've developed technology that allows us to ensure that the output of the 3D output matches the 2D file. And I want to introduce Graham Bredemeyer, one of my colleagues at ZVerse.
Hi, my name is Graham Bredemeyer. I'm the head of product here at ZVerse, and today I'm going to share with you how our 2D to 3D automation assisted technology checks the accuracy of the parts that have been converted in our process. So typically, when files are uploaded to our website from a client, what we're doing is breaking down the file, looking at the makeup of it, understanding what level of complexity is going to be part of the conversion cycle. Once a conversion's been completed, one of the most important steps in the whole process is making sure that the conversion is completely accurate. So what our software does is it takes the original 2D drawing, we take the 3D file, which we've generated, and we actually, in software, our software automatically generates a new 2D drawing based on this 3D file, overlays it with the original, and highlights anywhere where there might be inaccuracies in the drawing. So the black lines here represent the original file that we received from a client. The blue lines represent the inaccuracies, right? They represent the new drawing, and you can very clearly see as a CAD operator where things might have gone wrong. In addition to that, you can see red lines, and red lines in this particular instance are being used to highlight anywhere where attention needs to be called, where it might not be as apparent as those blue lines are. If you'd like to learn more, download our white paper, which can be found at ZVerse.com. Once again, I'm Graham Bredemeyer, head of product here at ZVerse, and I'll see you next time. Thanks.
So that's one piece of technology. There's some other cool pieces that we've developed over the years with our technical team and our geometric engineers. But you get a sense for what we're trying to do. The ability to produce parts locally on demand with digital manufacturing contributes to the circular economy and sustainable development goals, really in two ways. One is maximizing asset uptime, but also reducing inventory material waste and distribution emissions. And so, we're excited to be a part of this and identifying ways that we can contribute to sustainability going forward, and appreciate y'all being here. Sarah, I'm going to hand it back to you to run with it.
All right, thank you so much, David. Well, we're ready to get this panel started. I just want to remind everyone to please submit your questions as you think of them. Thank you, we've already got one in for after the panel. And now I would like to bring everyone up. If all of you could please turn your cameras and microphones on. All right, so I'd like to introduce Deborah Dull. She's the founder of the Supply Chain Network. We've also got Dan Brunermer here, a technical fellow from ExOne. Hey, Dan. Sherry Handel, Executive Director of the Additive Manufacturer Green Trade Association, as well as Amir Sasson, Provost of the BI Norwegian Business School. And so all of these panelists are here today as outstanding representatives in the industry regarding sustainability, supply chain or the circular economy. I'd like to give each of you a bit to introduce yourselves. Dan, would you like to start?
Sure. My name's Dan Brunermer. I'm technical fellow for the ExOne company. I just celebrated my 20-year anniversary this past May 21st. Very happy about that. And I'm looking forward to today's panel. I mean, MRO is something that we've dealt with a lot in binder jetting, especially in our casting business. And I can't wait to explain a little bit about how that's really saving a lot of time and money for people. And when we talk about reducing inventory, it's I just think additive is a great way to go. So thanks for inviting me today.
Yeah, pleasure to have you. Sherry, why don't you go next?
Hi, everyone. Thanks for joining us today. I'm Sherry Handel, Executive Director of the Additive Manufacturer Green Trade Association, also known as the AMGTA. And this organization was launched at Formnext in 2019, and I came on board as the organization's first Executive Director last February. And so we are a global nonprofit organization open to any additive manufacturer or industry stakeholder that meets certain criteria relating to sustainability of production or process. And my role is to grow and build the organization worldwide and work with our members to help advance sustainability in additive.
You're doing a great job. It's expanding pretty rapidly.
Thank you.
Amir, why don't you go next?
All right. Hi, Sarah. Amir Sasson, Provost of the BI Norwegian Business School and a Professor of Strategic Management. I'm here in the capacity of an author who wrote articles regarding 3D printing and its effects. So we will discuss that in a little while.
All right, and Deborah.
Hi, good morning, everybody. My name is Deborah Dull. I'm the founder of a global nonprofit called the Circular Supply Chain Network. We are run by volunteers from around the world. And we really create a space for supply chain professionals to come together and nerd out about what does circular economy mean for us. And part of that is MRO. A big chunk of the world we're shifting towards is to repair instead of building new. And the role of additive is also pretty incredible for what we're able to do with reducing the amount of number of SKUs, the number of suppliers, and shortening our supply chains overall. So looking forward to being here and sharing a few thoughts.
Yeah, and something that you're always saying is everything is inventory. And I love that quote. You also had a great one about supply chain professionals putting the inventory out in the world. So starting on the topic of inventory, how is the concept of inventory evolving for the digital circular supply chain?
Yeah, really good question. Thank you. Listen, we've got a lot of work to do. So to your point, Sarah, if all of you who are here can just look around the room right now and see the different items that's around you. In a circular economy, the idea is that we give materials more chances to add value to our global economy. And that means everything you see around you ultimately will go back into a supply chain at some point. Today, it probably will end up in landfill or somewhere out in the environment, and the material's not getting enough chance to contribute. So that means as supply chain professionals, we need to know a lot about the materials that are out in the world, and we need to be able to keep track and predict of, gosh, where's this type of material and where might it be in the world? How do we go capture that and put it back into a value stream? Some of this will happen through digital tagging of inventory, the cost of sensorization, and the way that we're using the technologies through the Industry 4.0 is allowing us to have a better idea of where inventory is today and create sort of a digital twin of the environment around us. Sometimes it's a little bit too much effort for what we might be tracking if we think something like a beer bottle that we can wash and bring back into a process. So really interesting discussions early happening across the industry about what types of standards do we need and what circumstances. And for me, of course, I think inventory is the world's most interesting topic. And so it's a fun one to be able to start breaking apart.
Yeah, thank you. And for spare parts, I think oftentimes we think of inventory at the beginning of the supply chain or throughout the supply chain, but there's now starting to be the term reverse logistics. I know you don't necessarily, that's not a term we want to keep using, but what does this mean for spare parts and the end of life of products?
Yeah, great question. You know, it's interesting. We've spent 150 years in a linear economy with everything going one way. And so we don't even really have the right nomenclature to shift the way that we think about the world. we still talk about how do we make items more efficiently, rather than shifting and imagining a world where we refurbish 90 to 95% of the items around us instead of building new most of the time. The reason I don't like to talk about reverse logistics is because I think in the next 5-6 years, we're just going to have logistics. And the idea that we don't need a supply chain that has a return leg, we just have supply chain that serves the community and the environment the way we need it to. So I think it'll be a really interesting shift to start watching. We don't spend a lot of time looking at returns and optimizing those. Sadly, a lot of what you buy online in return actually ends up being thrown away because we've become so efficient at these linear supply chains. And so this material never had a chance to add value. You got it, you tried it on, it wasn't the right size, you sent it back, and often it gets thrown away. So there is going to be a pretty dramatic shift, and I'm really excited to watch it happen.
Yeah, and you had a great slide. I just want to share that. I think you had a definition for circular supply chains.
Yeah, perfect. Thank you for bringing this up. And just cognizant of time, I'll just spend maybe a minute or two walking folks through this. So a couple of months ago, we got together, like I mentioned, as members from around the world to figure out what exactly is a circular supply chain. And there's 4 real components here. We'll come back to the interconnected piece at the end. But this idea of, supply chains in the end are really a series of inputs, outputs, and processes. And so if we think about the difference that we're going to have as we go into the future, anything that goes into a supply chain will come from a secondary or renewable source. Secondary meaning it's been used again. So the idea that all supply chains will get their materials from each other instead of from the planet, and sometimes from consumers as well. But the majority of waste produced in the world, actually, it never even makes it to a consumer. It's happening in our world, in industry. So we start with thinking about these circular flows that we heard earlier. We could also have renewable sources that might look like wind, solar, growing items like some types of woods, rubbers, etc. When we think about the world of spare parts, if it's a flow spare, we want to make sure that it has been refurbished, potentially printed on demand, so we're not creating more than what we need. For the really big expensive spares that take 1.5 years to build, obviously those are a prime candidate for refurbishment. Outputs, this one's pretty straightforward. Today we have waste streams and value streams. Tomorrow we'll have value streams and value streams. We call this major value streams, like whatever finished good going through that MRO process, and what we call a minor value stream, which today we call waste. It's really only waste because if you haven't found a customer for it yet, but once somebody starts buying that, it starts to become a new value stream for you. The process here, two important words, reduce and maximize. Reducing means let's use less than what we use today. And again, additive is a tremendous way to do that, to reduce the amount of material needed, to reduce the number of suppliers, the number of SKUs, the number of miles driven just to make that one part. So it's a great strategy there. And the second one is maximize, which is all about what MRO is. How do we maximize the life of that item? And the last call out, I'll go back to the beginning on the interconnected system. We started to hear a little bit about this, digitized supply chains that are automated, self-driving. We've heard the term digital supply network, and that starts to think about this idea of a digital twin for our industrial space, for us to be able to have a good idea of how we can circulate these materials back into each other's value streams.
Thank you, Deborah. That's really helpful to start trying to think of our everything has value. Everything can go back into the supply chain and continue having value. We want to, and a lot of this is coming on through evolution of technologies. So I wanted to move it over to discussing how manufacturing is evolving. Dan Brunermer, as we'll be producing more things locally, can you discuss how our technologies for production have evolved to enable these digital futures?
Well, yeah, I mean, I think that one of the things that's happened, of course, is just CAD itself, right? Our original owner of the business, Larry Rhodes, used to say, if 3D CAD had come first, we may not have CNC, or if additive had come first, we may not have CNC. And I think that we're seeing that happen. I think that when we talk about local production, you know, there's a lot of things involved in production and what we're going to call local, right? Like you still have to have powder produced somewhere. How do we continue to localize that? How do we continue to push out the ways of making the raw materials as well as the parts themselves? And the machines come from somewhere too. So when you look at some of the more exciting things that happened during the first hype cycle with MakerBots and all those like cheap machines, and everybody can have a machine everywhere. You know, to me, one of the questions is how do you further democratize that? And as you know, like I'm an expert in binder jetting. We're not exactly known for having the world's cheapest machines or the easiest to install and use. So, you know, there's a lot that's got to change in terms of training, education. Like I say, raw materials, distribution. I think to say logistics, Deborah, is a great, I think that that's also going to have to start encompassing some of the stuff that I don't really get into, like the business aspects, like, you know, the financing of the powders. There's that really new, interesting company that's taking on that problem. So, you know, and I think that the way it's also changing is just through simulation and, you know, when we talk about the 3 R's, reduce, reuse, recycle, you know, because of additive techniques, we can reduce in the sense that we can reduce labor, we can combine parts instead of just making this one reproduction. We can look at the total assembly in a more holistic sense, integrate more things, cut labor, cut time and resources in other ways. When it comes to reuse, I just had this little white paper that's going to get published in SAE Tech about how, you know, we talk about recycling powders, and in laser bed processes, e-beam, binder jet, we talk about recycling, but we don't recycle, we just reuse, we recirculate. And I sometimes wonder to myself, you know, what if every single metal from the time it was first, you know, refined was all turned into powder, and you never started with plate anymore? What would that actually change about how this whole debate would be restructured if there was just really, if everything started as powder? So, you know, I think those are my introductory statements I could make. And then of course I have plenty of examples.
Yeah, and starting with powder, powder, that's really how metal 3D printing works and forms a part. And I wanted to make sure to show some examples of some parts that ExOne has been producing for MRO. Dan, would you like to talk about these for a second?
Yeah, just real quick. I mean, like I say, we have this whole casting side of the business, right? Where we do, we print standard foundry materials, sands, furans, things like that, and we're able to do castings. And on the left, this is a common thing that comes up for the Navy, other departments of defense, where they have an asset that's been in use for 40 years. And this was originally a cast part, and now all those molds are gone. It may have 2D CAD on paper. It may have 2D CAD electronic, but generally not. And what's really interesting about how digitization has changed this, in addition to being able to do those things like reconstructing the 3D model from 2D models or from scan data, casting as a science is so well known that now we can actually model all these things, right? Like we can model mold flow, we can model solidification, we can figure out exactly how many risers or runners are needed, totally optimize the pour for the part, use only as much excess aluminum as needed, and you get first casting correctness. Like I guarantee that compression pump, the first time it went into production, they probably had to cast a dozen, 15, 30 before they nailed down the exact casting process that would make a DOD acceptable part to mil spec. And, you know, we're able to do all that work digitally now. And then on the right, that's just a really fun one, right? Like these people that like to restore old cars, that was like a 1951 something. You can look at the case study on our website, but it's just like a real fun thing that you can use this technology for all the great positive things. You can also do some fun things too, like restoring a 1951 Viper or something. So.
Yeah, and I think one key point to make there is it's not just 3D printing the part directly. Our digital manufacturing technologies have also enabled us to print molds. And so there's quite a variety in tooling for small volume production. So I think there's quite a variety of opportunities, legitimate use of this technology for spare parts, that and CNC locally as well.
I agree.
Okay, so I wanted to Dan, you mentioned a few things about reducing material and the sustainability aspects of additive manufacturing. We've got Sherry Handel here from the Additive Manufacturer Green Trade Association, and her organization has been doing some really excellent work in the materials space around additives. So Sherry, could you come on and discuss a bit how the concept of value and sustainability has changed in relation to materials?
Sure. Thank you. And I appreciate you loading up my slide.
Okay.
So existing research on sustainability in additive manufacturing tends to focus either on waste, energy use in production, or machine emissions to manufacture a part. And we don't have this full life cycle assessment where you're seeing from the material extraction up and through the production and assembly and distribution and use of the product up and through the products or parts life, what the environmental impacts are all along the way. And to really understand how additive is doing from a sustainability standpoint, when compared to conventional manufacturing, we really need the data and metrics. And unlike conventional manufacturing, there's a ton of data on every conventional manufacturing process you can imagine and how it compares to one another. With additive, we don't have that. We have very little, and certainly life cycle assessment, LCAs, are lacking. So we were founded to promote the environmental benefits of additive manufacturing. And to really do this effectively, we need to understand what the environmental impacts of AM actually are. And we want to commission independent, ongoing, and rigorous life cycle assessment research. And when possible, hopefully it will support the claims that are being made that additive is a more sustainable production process when compared to conventional manufacturing. So it really does depend what you're comparing it to, what method, what material, et cetera, et cetera. As a first step, I'm still on the prior slide. I'm not quite there yet, sorry. Yeah. So as a first step, last June, the AMGTA commissioned a systematic review of the existing literature in metal AM sustainability with Delft University of Technology. For this research, we selected Dr. Jeremy Faludi, a leading researcher in the field of sustainability engineering, who has a strong background in 3D printing research. We felt a summary of what AM metal research is currently out there would be a good starting point as we begin to explore new research topics. Dr. Faludi's team examined academic research that has already been published. And this report is free and on our website at amgta.org. Just go to the resources section. And there's a lot of information. I'm not going to be able to obviously cover it in this talk today, but I'm going to touch on some key highlights. But what we did find is that this report did unsurprisingly reveal that there's not enough good research out there to fully capture all the aspects of AM as it relates to environmental sustainability, and especially not enough to compare the impact of an additively designed part to one that has been optimized through the virtues of AM, because that's really the key. AM you can optimize through lightweighting, through clever geometry, et cetera. So our report is really focused on motivating, I think, our industry to do more. I think that's the big takeaway from this, is that throughout the whole entire paper, the researchers say more research is needed, more research is needed. We need to learn more. So let's learn about impacts of material choice. This is the slide on, here it is. Yeah, this is the one that one of the main impacts, the primary impact environmentally, is the impacts of embodied materials. And the second is the energy use of machines. So first in the life cycle of any part is the mining the ore and processing it into the actual pure metal. And this process includes shaping it into a form that is useful for manufacturing, like ingots, or in the case of AM, ultra-fine powder. As you can see from the graph, different materials have very different embodied impacts. Aluminum has about double the carbon footprint of stainless steel, while titanium is about well over 7 times that of stainless steel. And processing these refined materials into powder really doesn't add that much impact when you look at the whole embodied impact of the material itself. But please note that these numbers on this slide are for virgin metals. Recycled aluminum has 95% less embodied impacts per kilogram, so it's even better than recycled steel. And this is definitely another area for further study. But a material's impacts don't just end with initial processing, they also influence manufacturing impacts. The higher the metal's melting point, the more energy you'll need to fuse it during printing. And higher thermal conductivity means the heat you apply to fuse it will be dissipated more, thus reducing efficiency. For laser-based processes, the reflectivity also matters. More reflection means less of the laser's energy heats the metals to fuse it. This makes aluminum's processing energy higher than you might expect. So reducing material impact should be a priority in sustainability initiatives, that given that it is the largest percentage of environmental impacts are caused by the materials themselves. And material impacts can be improved by optimizing part geometry to reduce mass, choosing materials with lower embodied impacts, and by recycling or reusing materials at the end of life. So that's just a general overview. And I'm not sure how much more time I have. I want to be respectful, but I just want to say one of the key challenges, again, is that we don't have this life cycle assessment. So we are commissioning 3 studies. One we completed, which I just talked about. We have 2 this year. The first is an LCA that we're doing with ExOne, one of our founding members, partnering with us on this project. And it will compare binder jetting AM with conventional manufacturing of 3 impeller parts. And we're also going to not only do the LCA, which can measure up to 18 environmental impacts, including carbon emissions, but we're also going to be looking at the impacts related to emissions of principal greenhouse gases and local air pollutants and the social impacts that pollution has. In late summer, early fall, we plan to commission an LCA on laser powder bed fusion of an aerospace part as compared to a traditionally cast production process. And we will have those studies available for free on our website as well.
Thank you, Sherry. This is excellent research. I know that there's, please do check out their website. The next slide was going to be all of the members. There is a large and growing list of members in the AMGTA. ZVerse just became a member. I invite anyone who's involved in the industry to please go check out their website. So all of these factors are coming together to enable a global trend towards localization, and that localization will have digital manufacturing at its core. Amir has specifically researched this in his professorship, and beyond the customer demand and experience of receiving things locally, customization opportunities, what are some of the business factors driving this? And this is really going to be the key decision maker for companies moving forward. So the systems thinking that we talked about, I'd like to have Amir discuss some of his research there. Oh, hey, Amir, your mic is off.
Yes, I'm ready. Thank you, Sarah. I'll try to, in 3 minutes, go through about 250 years of history. That's a bit challenging. But if we really analyze the last 250 years, we've seen one big thing. It's not industrial revolution, it's concentrating production. We had production of many products in villages, in households. That happened for centuries and centuries. And then we basically saw a process where we concentrate, and then after World War II, even more concentrated production. Larger units, right? Small number of extremely large units have popped out. And then in the last 50 years, what we've seen is the fine slicing of those value chains. We used to own everything, and then we start parting it. Technology in one part, marketing in New York, digital in the Silicon Valley, labor in the Philippines and China, and so on and so forth, all cost driven. But those two mega processes are actually being reversed as we speak. So we spend some time, it's when I say it's me and Charlotte Johnson, Stanford PhD, used to be at least, are trying to understand what does that really mean for how the market's going to look like, right? Next slide, please. So the market for us is going to look very different than what we know. Some of you already spoken about, the orange/reddish color, all right? The distributed production, instantaneous production. But for me, one of the most interesting things is shared production. Currently, every manufacturing manufactures for itself. It's not that common to share one industrial production with hundreds or maybe thousands of producers. And 1,000 producers or 10,000 producers are basically us individuals. We will produce. So we spoke about some of those value chain challenges, global distribution of raw material, but actually global distribution of raw material is not really a big value chain challenge. The problem is, of course, secondary parts. But if we're not going to use secondary parts, moving raw material, that's the easiest part in the logistics value chain, right? It's much more difficult to move semi-finished products. Local distribution is also relatively easy. We do it all the time, right? Where do you get your grocery during the pandemic? So all those things we have looked at. The blue part is what is interesting. For example, DAN products will not be sold for the home printers, right? The home printer is very much like the ink printer that you have today. They'll be simple, very low number of raw material you can access because you're not going to have basically everything in your garage. Then you're going to have the street corner printers, so what we call the 7-Eleven of everything, right? And those may be by DAN's products, but not necessarily so. But they will have more raw material because they have, you know, certain storage in the back and they can produce more things. And of course, you go and do your groceries, so you're going to pick it up. Then we're going to have the raw material clothes printing, explosive. You're not going to do it in the 7-Eleven, right? Chemicals, but you may actually do it next to where the raw material is being produced or extracted. And then what we care about and what we really see is the super centers. The super centers are really these sharing production units. The ideal place for them is probably the landfills. Why? Because it's very close to everything. They will basically be producing in your local area, in local maybe 100 square kilometer or 100 square mile area, they will produce most things. They will be out, i.e. not in the city centers. They will have enough space, and they will basically store the different material needed to produce a large number of products. And by the way, Deborah, as you were saying, they will also unproduce things or reproduce things because we already have the logistics ready. The interesting thing, right? The EU just changed legislation, right, about requiring products to be there for 10 years. Well, I assume that the next stage of legislation will be, wait, where is your 3D printing and the reprint material, such that we make sure that everything can be reprinted. The last thing the last point that I have is really where we're going to see digital manufacturing in the super centers. So what will they produce? So here we borrow a little bit from Anderson. They had a great thing. Basically, let's look at product popularity. If they're extremely popular, i.e. the demand is in the million and the billions, so we are not ready, right? Direct digital manufacturing is not the solution currently, right? Because molding is probably much more efficient to produce that in large numbers, right? Both environmentally and when it's come to the cost of that. But as we move down this popularity line, right, we're going to be in an area where it's actually beneficial for manufacturers to somehow produce in this logic of scale economics, the traditional manufacturing. But then when frictions come into the production process, actually not stop production and restarting it, but actually do it through digital manufacturing. And if we go all the way to the right, that's when we really need very, very few products per se as a global demand, and there, digital manufacturing will take over. So what we spend time on is really on trying to understand where digital manufacturing will play part. We all know that on the right side of the distribution, it will play a lot of part, right? That's like, started with printing in outer space and all of those kind of army need. But as we go to the left side, we know that manufacturing and non-digital manufacturing will take over. So the issue is really defining the centers, right? The center of that distribution, and that's what the super center will take. And as the technology develops down, we're going to see that graph moving to the left, i.e. more, right? You're going to move to more and more popular products, but never all the way left. Thank you.
Yeah, so digital manufacturing being most useful for the small volume and the repair part market definitely fits into that at a local level. And as you're saying, moving up that popularity chain. So over time, and we're actually seeing this, the big trend in additive right now is we're ready for production. So moving up there. I did want to make sure we have time for audience questions. And so I'm going to move over to, we've got one from Stephanie, and this is for all panelists, please, please respond to these. We've got one from Stephanie Hendrickson at Additive Manufacturing Media. With additive manufacturing, advancing democratized and distributed manufacturing and right to repair legislation on the rise, who will own MRO in the future? Will OEMs adopt 3D printing to supply their own spare parts, or is it more likely that 3D printing service bureaus and contractors will fit this niche? So what do you all think?
I'll take
Oh, Amir, I think your microphone's off.
Yeah, yeah. I mean, my view is the following: the traditional manufacturer can license, right? They will license and get the fee every time we print, right? That's a great business model. You don't need to do much, and let the supercenter print it, right? That's a great business model for both.
You know, on this, Sarah, it's really interesting when we think about what the future will look like in shifting, like I had said earlier, towards more of remanufacturing. We also have a number of discussions happening now as the relationship between additive remanufacturing and carbon emissions. Right now, carbon accounting is somewhat lacking in trying to understand who gets the credit when we remanufacture instead of build new. And I think the way that that legislation starts to move will inform who then takes on the role of remanufacturer. If there's a huge carbon credit, I can see a massive incentive for OEMs stepping up to do it. They know their parts the best. But we also could have certified maintenance owners. And to the idea of shared production, I think this idea of owning a line completely will disappear, and we'll start to have more standards and then very clear guidance on the proprietary nature of whatever it is we're building. So I think we're going to have a bunch of shared infrastructure on a computer or car or whatever the case is, and then the proprietary piece inside. So I'm really excited because the right to repair pieces are starting to catch on in consumer land, and I'm hoping we'll also swing into industry as well.
Yeah, that actually relates to our next question from Joshua Cooper. Are the current barriers to the sustained implementation of MRO currently primarily technical or political? So you mentioned one of the challenges, the legal aspects. What technical or even more legal aspects do we have to overcome?
I'm going to say it's an option 3, which is that it's really tough for us to collaborate across outside of our enterprises. Actually, government has been doing a great job incentivizing circular business models, materials exchanges. Technically, the technology is here. It will continue to mature and become even more affordable and scalable, but that's not a blocker in many cases. We're seeing an issue with secondary materials markets not being mature enough or available enough, but the underlying root cause is that we don't have a good set of practices to work with each other across enterprises right now. Especially if I look at American markets, we're driven by capitalism, and the idea that we would collaborate with someone else is kind of like freaking us out a little bit. But we see it emerging in other markets, and I'm hoping that we can take those as clues to see how much economic growth is happening. So I think this piece actually starts to trip us a little bit more than we would expect it to.
Any other comments there?
Yeah, I mean, I'd like to just say, to sort of reinforce that, I mean, to me, what it comes down to is standards. You know, like I work on a whole lot of international standards boards like ASTM, ISO, DNV, and, you know, until we've all demonstrated that we have standards, until we've all demonstrated that we can perform to the standards and have that proof out there in the way of, you know, third-party verification and all the stuff you have to go through to get a true ISO, ASTM spec. There's going to be a whole tier of part suppliers that are just not going to come into the technology until they see it. You know, like if I'm a tier 1 or tier 2, I'm not stepping into this space to be a tier 1 supplier for Ford if I can't say that I can meet Ford's requirements every time. Ford can certainly do that. Ford can certainly make that investment and put something in their plant and play around. But all these tier 1 and tier 2s, I mean, until we have real proven stuff out there, I think it's going to be a slow uptake.
Thank you, Dan. And the next question, I think you'd also be able to help answer along with David. They specifically sent this to David. So from Martha Kellerhalls, from a non-technical participant, but strong proponent of the circular economy, what different materials are you able to use to create these replacement parts? So David, if you want to start, and then Dan, I think you've got a really strong input on all the different materials, or Davide, if you'd like to contribute too.
Obviously there's so much going on in the material space across so many different types of, from metal and nylon and plastics. There was an announcement last week of a partnership to investigate some new metal powder materials for oil and gas. There's just so much going on in the space, and I imagine that Dan and Davide probably have a ton of detailed information of what's going on, but it goes across all material types.
Yeah, and I would say when you compare those materials, so when selecting materials, when you compare those material charts on material properties, additive is legitimate. You can create good parts with additive materials that function in a similar way to the original part. Dan, if you had any thoughts there?
Well, yeah, I just want to say that, that's another thing though, that's like kind of an inhibitor in the sense that, a lot of times in an MRO application specifically, they want the material that the part was first made in. And so you might have a much better material, a much better, more modern solution that you can bring to the table. And there's a lot of things that are unique about additive, but a lot of times on that engineering drawing, if it says stainless steel 316, that's, like you have to play by those rules at first. And then, the toughest part of the conversation is getting them to move past what this immediate need is according to this particular spec, and to say, okay, how about if we, there's a common refrain, let's back up and look at the true requirements of the part. And if you can get people to back up and look at the true requirements, that's when you can really make the gains in things like materials, novel designs, really taking advantage of it. In an MRO application, many times, especially in the defense, when your hands are basically tied.
Thank you, Dan. All right, so for our, while we have our last question up, I'd like to put some polls up on the screen. This is a community data initiative related to the topics on the webinar here. And for our last question, I'd like to have everyone discuss the human element of this new ecosystem. So where do we stand in all of this? How will our workforce navigate this digital transformation? Deborah, I think you had some thoughts.
Yeah, I'm happy to start. Listen, we have a lot of discussions about how technology is going to take jobs, especially in the manufacturing sector. I see this as one space that's actually a tremendous opportunity for job growth. It costs less money to employ people in a circular economy. The math works out. There's more labor that goes in, but because we save so much money on materials, actually it works that cost per person hour is much lower. So that's good news. That means we can employ more people for the same amount of money. Also really cool is as we think about, again, shifting away from new builds, which has been in some cases fully automated now, into repair, and we start thinking about lot size 1, robots don't know how to do that yet. And so we still need to have extraordinarily skilled labor to assess, and sometimes there's ways that technologies can help us understand what's needed in a repair, and that's a great head start. But for the most part, all of this is down to really skilled labor through our supply chains and value chains. I think about the role of augmented reality glasses. We're starting to see that already now in maintenance and repair of large equipment. And I think as we start shifting away from what today is an aging workforce, really into the next generation of engineers, I think these can be a great kind of apprenticeship type of a tool set kind of support. And I know that Dan, we had talked a little bit about that in our prep call for this around what your teams are already looking at there.
What do you think, Dan?
I'm sorry, I kind of lost a little bit of that. There was like a little blip in my network connection.
No, I'm really thinking about like the role of AR glasses and apprenticeship programs.
Oh yeah, I mean, hey,
engineers.
Right. Well, I think we announced it Can I talk about it? We're a publicly traded company. I think I can because I think we announced it. We use AR. AR training is our first method of deployment and training now for our largest sand printers. Like basically you go through several rounds. There's like some presentations, then we send you out some glasses where you have the VR AR experience. Then you come on site to work with the machines, you know, and then in terms of like the way we train our service personnel, it's very similar. We have like we partnered with, you know, I can't remember who, I'm sure it's in the press release, but, so like, this is like a method of first choice for us now. And it's great for sales too, frankly.
Awesome. I didn't know that about you guys. Really, really cool. Does anyone have any last thoughts there? And then I'll move on to our last little bit.
Yeah, Sarah?
Yes.
Just to follow on Deborah's thinking about skilled labor. So skilled and extremely skilled labor will have a lot to do in the coming 2 generations, right? We have enough products in the world. And if we're going to change all of them or make them a digital copy of both production and destruction or reproduction of them, that's going to take lots of engineering. The problem is what happens on the other side of the skill distribution, right? The low side of the skill distribution. What type of jobs those people will do the minute we close down some manufacturing, for example. In percent, manufacturing is really tiny. Even in the US, it's around 13% of your GDP, right? 7% in Norway. So 17 in China is 30 and so on. But there are still millions and millions of people there. So it's not just the high skill going to have great time, especially in engineers. We need to start thinking as educators, how we educate the others, to allow them access to the economy.
Thank you. Well, it has been a really interesting discussion today. I'd like to thank all of our speakers, David Craig, Deborah Dull, Dan Brunermer, Sherry Handel, and Amir Sasson. And we are about to start our networking breakout rooms. So I think, Laura, you're going to share the link over in chat. If all the speakers could please click that link and then head on over to the breakout rooms, we'll get that going while we do our last few slides. I'd like to once again mention 3D PBM as our excellent media partner. Thank you, Davide and the 3D PBM team. Their sustainability ebook is featuring all of us, as well as many other companies across the industry and studies and stats on sustainability in additive manufacturing. And the link is in chat.
Thank you.
Thank you, Davide,
for having me. It was a very, very interesting, really very, very practical. I really appreciated the fact it was a very, very practical and interesting discussion. Very, very, very good insights.
Yeah, I'm hoping that all of you who are in the audience today can take this back to your companies. Just bring up a sustainability initiative. Bring up, if you're going into additive manufacturing, bring up that this could potentially contribute to it. You might have to collaborate across departments, but this is happening now, and it's going to be big. So ZVerse also has a white paper, that demo that you all saw towards the beginning of the webinar. If you'd like to learn more, if your supply chain leaders, advanced manufacturing, sustainability, or field service leaders would like to learn more, please share that link with them. This is a direct link to download. You don't have to enter any more